This is part 3 of my cantilevered crossover design. I will leave links for the other parts in the description. In this revision I have included 10mm belts in an attempt to stop them slipping. I've also listened to quite a few viewer comments and lowered the pulley idlers to help achieve this. I have converted this prototype from direct drive to a Bowden system. This was primarily for ease of tuning rather than reducing weight inertia. I am the first to admit all helps with this cantilevered design. Removing the extruder from the hot end allowed me to streamline the bearing spring retention system. This is just a crude design created for testing. I would hope a final version would be much more elegant. I am still using the FDM parts assembly for testing, but I may go back to the CNC parts if I can see an improvement in the print output. These are the current speed settings for this test from the slicer. Although this design may seem a futile experiment to some people, there are some positive things coming out of this project. For example, the cantilevered Z-tilt and bed mesh construction is consistent and working very well. Finally, we have a little boat, not a very good little boat, but a boat nonetheless. I wanted you all to see the good and the bad with the current state of play. Clearly a lot still to do if doable. This printer has not had any tuning yet, but obviously tuning will not resolve all the issues we are seeing here. Adopting the 10mm belts and lowering the belt and idler position seems to have cured the belt slippage issue. However, there is clearly still a lot of issues with the print quality. We will have to see how the next series of revisions pan out. This particular design is still very much more proof of concept rather than a functioning 3D printer. I want to switch to one of my other experimental printers next, but hopefully we'll be back with another episode of this cantilevered printer design soon. Thanks for watching.